Recording in progress.
And it's and you can on a waiting.
Oh, okay.
Yeah, it's connected with
Some further line
Right.
down, is that true?
Oh, yeah.
Yeah.
Okay. Great.
All right, Luke. Right, yeah, because I saw that here in probably wouldn't be here.
Are you sure? No, take it back.
Yeah.
Yeah, I think I'm pretty good. All right. Is this our final crew? All right.
I know.
Just real quick before I get started, we're on a compressed time scale. But I do want people to know that we're gonna run everything in here live. There's one code block I'm kicking off right at the start. Just so we can kind of not wait for anything, but just so you know, we're gonna explain what that is in a moment, but we are gonna kind of run through these live. So, when I first was asked to present at this summit, I threw out the title, leveraging the cloud for agile AI development. And Bingwei said, that's great. And I wanted to do a presentation that was everything I kind of hate about the cloud, right? So I'm constantly up against authentication issues. I have to figure out how to containerize everything. I get surprise credit card bills because often I'll prototype just using my own accounts, all sorts of things. But I do just want to say, like, the demo we're doing here today, 5 years ago, 10 years ago, it was absolutely impossible to do. And there are several key workflows that the cloud is enabling for AI and ML that I thought it was kind of important to talk to. And we're going to demonstrate each of those today. Now, just as a way of introduction, you can't really see a lot of the text. That's okay. Just as a way of introduction, my name is Luke Schulman. I'm a customer-facing data scientist with Datarobot. A lot of my demonstration today is going to touch on Datarobot topics, but I'm going to be using cloud infrastructure from a combination of Snowflake and GCP. And I think what you'll see is these are practices you can really apply if, unfortunately, you're not going to use Datarobot, which I totally understand. So you'll kind of see what AI APIs are becoming available from the cloud providers, what they're really good at, but then also what data scientists kind of need as part of their workflows that you can get from another. You can also add in and take advantage of what the cloud is giving you. So that's kind of what we're going to walk through today. All right. Just a little bit about Datarobot as well. We've really originated the idea of automated machine learning and ML operations over a number of years. This is just kind of we call this the logo splash. So you can kind of see everyone we're working with. But let's get into kind of really what I wanted to walk through today, which is, why Agile AI, right? Why do we use this topic? So first is, when you think about a machine learning problem or an artificial intelligence problem, somebody quoted actually, Minutia in an earlier session said 90% of that work is data cleanup. So data scientists, we ask ourselves, well, how much data prep is this going to take? And that's your time to value. If it's going to take months to pull data together and derive what the features are going to be and transform them, you're not going to deliver value until that process is even done. The second one is, how quickly can you iterate or experiment? Because until you pull all that together, you don't even really know if your modeling is going to be successful at predicting the target that you have. And that's your time to production. And then the last one is, how do you sustain that success over the long term? And I joke that this is your time on vacation, right? A year after a model is developed, how are you going to know that it still works? How are you going to keep people from calling you when you're in Hawaii or the Bahamas because the model hasn't start predicted? One of your, I noticed for the CVS folks here, one of your colleagues, Ali, he, in a recent presentation, brought up an email that he got about a model he developed 3 years ago that is no longer making predictions. How do you onboard someone new to be able to support a model that was developed that long ago, right? So time to value, time to production, time on vacation. So the other reason why this is important is the demand for modeling continues to grow. So the gray area here that you see on this chart is roughly the current capacity of groups, even groups that are very high on their AI maturity scale, their capacity levels off. But the demand for modeling across their organizations is really unlimited. I haven't been at Datarobot that long, but I am astounded by the myriad of different models that are going on the model backlog of our customers. I put some on here. These are not jokes. These are real models. Now, in one case, cloud infrastructure spending, that's the model we use at Datarobot, because let me tell you, our cloud bills are super high, right? When you run a SaaS organization, they're high. World Cup goal scoring. Yeah, that's a model we're launching because it's a good marketing platform. But if AI is good marketing for you, that's a model you now need to support. And when customers visit your website and want to know how many goals are going to be scored, it's got to work. Actually, they're not currently a customer. Capital One is advertising on NPR, which I'll admit to listening to, that they fight fraud with random forests. Like these models, even if they're in marketing, they have to work, right? So how do you unlock the productivity so your current capacity can meet that demand? And that's really what we're talking through today. So has anybody ever seen this question? CBS folks from other organizations? I've worked with a ton of healthcare organizations in my career. Always comes down to how can we identify high cost, high utilization patients? If you're familiar, and it's a little dim on here, I'll read it out. If you're familiar with electronic health records, the records your doctor keeps on your care, for the most part, over a 20-year battle, they've been standardized on a format that looks a lot like what I'm showing here. So you have things like observations, immunizations, encounters, procedures. This is how the data kind of gets put right into the record. So how long is it going to take to go from this raw format of this data to answer this AI machine learning question? And that's what we're going to walk through as we try to answer that first question. How much data prep or cleanup is necessary? You know, when I say data prep, a lot of people think of connectors, they think of joins, they think of standardization. But you also have to think about, well, what are features of this data that would be indicative of a result? And that's really something that you can rapidly accelerate and automate. So let's actually take a look at that here. I'm going to change tabs, hopefully. I'm actually opening Snowflake. Snowflake, for those of you who aren't familiar, it's a big, infinitely scalable database. It's analogous to BigQuery. You can see here in Snowflake, we are querying about 25 tables, 3.5 million rows of synthetic health record information. So these aren't real patients, so don't worry about that. We have their claims, their observations, their imaging studies, their procedures, their encounters, that sort of thing. This is where the cloud really accelerates, because this is a pretty big data set, and we can still do really amazing queries, like look for every single mention of the word car in every single medical note for every single one of these patients and count it up, and that took 2 seconds, right? That is incredible. If you've ever worked on SQL Server and tried to optimize regex with indexes across text fields, this wasn't possible 5 years ago, right? Just to kind of show you from a chart, the words of text for these patients vary from just maybe 1,000 words to over 400,000 words of text, which means some of these patients have a record the size of Moby Dick at the novel, that thick, right? And you're able to churn right through it, but that's great. But somebody has to think of the fact that we want to know how many references there are to the word car. Having a car can impact whether you get an appointment. It can impact how easily you're going to stay on your treatment. You know, if you need dialysis and you have to go there twice a week, having a car could be the #1 impact of that. So somebody has to think of that and say, well, why don't we look in their record and see if they have a car or not? You have to constantly brainstorm this. And this is what is taking so long in preparing for an AI project. But you can actually accelerate all that and have AI tell you what's really important, and it'll actually find these automatically. So how do we do that? So, so in Datarobot, so in Datarobot, we can actually automate these associations. So we can actually go in here and we can configure these relationships. So you can see here, I've created claims, observations, care plans, all from Snowflake, all connected to the primary data set. And using the power of Snowflake, we can push down into the Snowflake SQL area, and we can start generating all sorts of features like this. So, yeah, no, go right ahead.
So how the infrastructure was set up? Is Datarobot running on where? Does that need to be on the same like a cloud provider as the Snowflake, or
Yeah.
they can compete separate?
Great question. So it doesn't need to be. Most of our customers are deploying Datarobot on like a VPC, or they're using our SaaS platform, in which case the connection with Snowflake is via secure API. So it's actually using Snowflake native APIs to access the data. If you're on, if you're on BigQuery, it'll use OAuth or service accounts, not and it'll access the data that way. There's kind of a range of connectors. Yeah.
Then do we need a data movement from Snowflake to Datarobot cluster, or it doesn't need to?
Doesn't need to. And that's actually what I'm saying is this system is actually running the SQL to identify these features on Snowflake. So it happens insanely fast. And that's why at the top of this presentation, I actually kicked off these projects. We're going to start seeing results for these projects that I'm describing before the end of my talk. So in about 5 minutes. Okay. So what are these? I'm zoomed in here a little bit, but what are these features that it's actually starting to find? Well, one of these is, what is this one called? So this one is called the primary patient insurance that is most frequent over the previous 180 days. There are close to 1,500 of these features that have been identified, over 1,500 explored features and 450 that are left. The one that I actually like, let me actually pull this one up. Day of week. I think I can't find it. There we go. Yeah, so check this one. So this is the, nope, that's not the right one. There we go. So this one is the word count of observations counted over the previous 180 days. Let's actually take a look at this chart. So you can actually see how it works on this linear chart. So what this is doing is it's looking at the description of every provider observation that this patient has had over 6 months. It's counting all the words, and then it's creating the maximum word, the word basically with the most mentions, and using that as a feature, right? It'll also look at the entire spread of words and just use it as a JSON text block. It'll look at entropy of date features. It's going through all of these possible permutations to identify the features. And it will, if CAR is significant, it will automatically identify that engram and use it going forward, right? So nobody had to sit down in a 4-hour brainstorm session and say, well, let's do a regex for CAR and a regex for diabetes and on and on and on and on. You can let the system automate this flow and do it for you. Okay. Now, one thing I wanted to also show is not all of these admittedly are going to be super important. So once you have AI models that are building off these features, it'll start to tell you what's really impacting the result. And so here we can see actually the most important feature in this is the raw text of the note. And this is another really important thing. So this is the raw text of the provider note. You can see some samples of it here. No chief complaint, the history of present illness. These are actually quite large in practice. As I said, these are up to 350,000 words. This is the most important feature. This is another key thing. Do you have to process text on a completely separate pipeline from your categorical and numeric data? So here we have a feature that's just the number of visits this patient has. Can you process that alongside the text that you have as well? not all platforms can support this multimodal data. Another thing that we actually have available, I'll flip back to the data tab and I'll kind of show this off.
Oh, sorry, just to confirm, even the modeling part, you do not need the data to be moved to Datarobot?
So, yeah, this is really interesting. My colleague Chandler can actually jump in on this too. So Datarobot, one of the things that differentiates it is we want to give you an interactive data science experience, as if the data scientist is sitting here working with the data. So that data is going to get extracted into memory and the models are going to be built on it. So you can think of it having a cluster behind the scenes that it's going to build each model on. So yeah.
So can we say like a data cleansing happen on the data source side, like on Snowflake? But the modeling, building, algorithm running, that actually needed the data to be extracted to Datarobot.
Yeah.
Okay, so there's still like a high network bandwidth requirement. Otherwise, because you have a huge amount of memory running, but you need the data to traverse from the network to network, right? So that's still the case, right?
Yeah, really, network latency doesn't really come up in situations like this. So part of the benefits of working with Snowflake and eventually kind of a BigQuery is being able to push down the compute there. So from our end, what we're saying is, this is the schema that that's been identified. These are the connections. This is the date window I'm curious about building features around. Push down into Snowflake and develop those. And then we're going to import those one tables of view at Datarobot
Exactly.
to just do modeling. So all that feature engineering is done there. And so, but what Luke is showing is the dwindling down to what's useful and what's important. So we want to go from big to small. To your point about cleaning, I'll just add this. AutoML is not just algorithms. Depending on what you consider to be cleaning, handling missing values, cleaning up the leading white spaces in the n-grams, the text pipeline, that's all part of the pre-processing that's embedded within the modeling itself. It's not just like run random forest. So,
yeah.
Well,
Yeah.
for data cleansing, I understand it, but for a lot of algorithm, I do not think they are currently available on the BigQuery or in that case, that it needed to be run.
Yeah. But again, if you're deploying Datarobot in your Google environment, which you can do, there's no ingress.
Yeah, that's actually the first question I was if Snowflake is on top of GCP and Datarobot also on top of GCP, then you use the private
Exactly.
network.
Exactly. It's a data connection that's being leveraged.
Okay.
So to Chandler's point, what's being developed here, these what we call blueprints, they are processing text, summarized categoricals, numeric features, all in entirely different ways. And so again, this is another accelerator. You're helping the data scientists automatically determine what are the best ways to impute and encode this data, no matter what kind of data it is, whether it's the text of the note, whether it's a summarized categorical over the last 100 days, whether it's the top n-gram that's been used in a big block of text, whether it's an image, or even, I just showed off, some people saw it on the screen, even if it's a geospatial feature, is there a geographic relationship between these rows? All of those are going to be automatically derived. Okay, so, in the interest of time, why is this important? We looked at the feature lineage. So why is this important? So this is actually adapted from one of our customers. This is a life sciences firm. They launched 4 models into production that actually used images alongside their categorical data to look at which which proteins coming from a bioreactor are going to be the most successful for this treatment. This reduced their experimentation time by up to 80%. So their most highest cost employees, their highest cost resources, the research scientists are actually reviewing these proteins and developing hypotheses to reduce their decision time by 80% was absolutely invaluable for them. They estimated this was over 280 person days per year that they saved. And it's because of the ability to take in multimodal data and derive features from it automatically to allow them to rapidly experiment and iterate on. Okay. All right, let's go on to question 2. We're going to kind of continue our journey. So how quickly can you experiment and iterate, right? all predictions have, boundless applications, but kind of leveraging the cloud and leveraging this power of compute, you could take the same data set and run multiple hypotheses all at once and use the learnings from each of them to help arrive at the correct model faster. Returning to our use case here, right off the top, when I see this question from a customer, immediately as a data scientist in my mind, I want to build regressions against various targets, against healthcare expenses, against the number of visits, the number of diseases. I want to build classifications to see, well, who's high cost, who's low cost. I want to do a clustering algorithm to see if certain patients can be statistically differentiated from others. Are there patients that are anomalous? These things all help to describe the data set that we're working with. In a true, an end-to-end data science project, you need to try all of these to get to your result. And luckily, with platforms like this, you can actually automate running these. So as you can see here, I'm spinning up projects to regress against 3 different features. I'm also spinning up a clustering project and an anomaly detection project. Again, we call this a model factory, right? Where we can take a single data set and we can create a factory that is going to do multiple different modeling approaches. And then within each modeling approach, we're going to try we're going to try 50 or 60 blueprints that are going to try to predict that, all in one function call, as you can see here. Now, look, I ran this, that was at 3:30. It's now 3:55. The project we've been looking at here is from October 16th, right? So I ran this on Sunday. What I'm going to do is I'm actually going to pull up all the projects that I have here in Datarobot. And let's take a look here. Yeah, so you can see all these have just started to run, dated today for the 20th. In just 20 minutes, each of these projects has already returned modeling results. So I'm going to go to the 20th, and I'm already starting to see validation scores come back. In most other platforms, what we just kicked off would be an overnight job, certainly several hours before you saw any type of scores. But already, because of the ability to scale memory across a cluster, the ability to use compute coming from the underlying hyperscaler cloud instance, we're already starting to see how XGBoost, how gradient boosted trees, a generalized additive model, and we're seeing all these results and we can compare them against each other. And more than that, if you're not a data scientist, this interactivity can help explain to, a stakeholder how these models work, and you're seeing them all get explained through the same framework, right? So here we're looking at the healthcare expenses, and we can compare the models for healthcare expenses. How well did they do against one that modeled disease state? How well did they do against the clustering and anomaly? Which ones are really working, and how do we put them together to get to the final prediction that we want? Okay. I'm actually going to flip us back to the one I did on Sunday. This is after a couple of hours of running, and you can see this has generated over 61 models. What are the differences between these models? Well, a lot of the difference comes from how the data is transformed and encoded for machine learning. So we can see at the top that the most high-performant models are actually using a reduced feature set, and they all use certain n-gram text modeling. And that's telling us something about our data. One, it's telling us we have too much data. We have features that are extraneous and are not necessary. The less features you have, the more sustainable the model is in the future. This is kind of, we talk about human in the loop. I like to call this as like machine-human interaction. The AI model is telling me something about the data. I can now go fix the data or restrict the data set, and I can now rerun modeling and hopefully get the same or better result. Or I could try to bring on a different data source to improve the scores that I'm getting, whatever I want to do. All right. Any questions thus far? Okay, so next up, so I like to close these with a, kind of looking at one of our customers as well, right? So This is a customer, Nestle, that we work with. They have a data science team of 8 people. That team, using a factory that I just showed you, created forecasts, close to 60,000 separate forecasts. Now, why would they need 60,000 forecasts? Well, if you consider every SKU that they sell in every segment of the world that they do, it quickly gets up to that many. And the reason that they can do that at scale and then scale that up to over 6 million predictions a year so that they can understand how these products are going to sell at the product level, at the region level, they're saving hundreds upon hundreds of hours of data scientist time because they can automate all the way through this process. Okay. Great. I mean, we're not talking a lot about forecasting right now, but especially in candy, which is the bulk of their business, it's highly dependent on holidays. Holidays are different all over the world. So a forecast that they build that's using a US calendar, it doesn't work in another part of the world, whether that be Asia or Africa. So they have to do these localized forecasts for every product that they sell. There's also a range of products that are only coming out at holiday season. They don't have long history, so they need a whole different kind of forecast approach. And that's how you end up with 60,000 models. We call these forecast factories. Their idea is like, we want to forecast everything, not just sales, but also deliveries and shipments and so on and so forth. All from a team of 8 users. All right. The last section of this is how do we sustain success over the long term? So I've seen a lot of machine learning projects arrive at a model that has a lot of promise, but that model doesn't go into production. I wrote on here, a Jupyter notebook is not a model. Okay. A Jupyter notebook doesn't go in production. And even though in some systems you can schedule the notebook to run, it's not a model in production. So one of the things you can leverage is because you can run this model so effectively and so fast, you can generate things to really document and understand how this model works. We call this compliance documentation. And I'm actually, so you notice right here, for this model, I haven't run any of the compliance documentation. But the compliance documentation does a series of tests on the model and documents how every part of it works. I'm actually going to flip over here. We're actually flipping into Google Cloud. And this is a Google Cloud Vertex pipeline. This is a model being trained in Vertex, and then it's pushed up to Datarobot, and the documentation is generated by Datarobot. So again, we're leveraging kind of the multi-cloud nature of this. We can take models from other systems, leverage best-in-class APIs to test the model and understand how it works. But I'm using this to kind of give you a sense of what does this documentation entail? Well, it shows things like how every feature in the model is being used, what performance we'd expect of this model going forward in production, the feature importance, something that we kind of looked at. You need to gather this documentation together and come up with a plan to train models in order for them to stay in production in a sustainable way.
Is this a general available on Vertex AI, or is it just for this specific project? If you can go back to the Vertex AI part, like the diagram, that's a Vertex AI, right? Like the URL, like the document specifically for this is generated by Datarobot.
The documentation and the testing of the model is done by Datarobot. The model is a Vertex AI model, and you're taking advantage of the orchestration of Google or Azure or AWS to help that model get hosted in the most scalable way possible and also get tested and validated so that it's ready to go to production.
Is this requires specific setup, or
No, we can do this now. I think. So we have like how we have it set up in our environment. You know, once we enable Vertex AI, you can do this whenever it's enabled.
It's essentially a composer. It's just like Airflow.
Yeah.
Oh, this is a composer.
No, it's not.
It's similar composer. It's from Google. It's slightly different.
It's Vertex AI. You guys use ML Flow, right? Yeah, it uses Kubeflow under the hood.
Okay. Okay.
We kind of refer to this as the production gap, right? Every organization has a ton of teams and they're all going to use different data science systems. Some are gonna use R, some are gonna use Python, others are gonna be using Scala and kind of some of the more Spark frameworks. To get those models in production, you have to monitor, manage, and govern them no matter where they're gonna be. And that's a key layer that involves registering the model, testing it, and understanding how it's serving results. We'll look at that in more detail later. And then you need those models to run really anywhere. And so you can run them in Datarobot, which is great, run them across Kubernetes and Kubeflow or in any other type of kind of hyperscaler cloud system. Running them there gives you, again, unlimited scale, but most importantly, also gives you scale from 0 up to 1 billion predictions, because you can never quite tell exactly how many predictions your model is going to need, whether it's in batch or in real time. So you got to be able to run them anywhere. So we call this the production gap, and that's what we're trying to fill in. When I look at Datarobot's MLOps workflow, I see over close to 50 models that I'm monitoring actively that I have quote unquote in production. And you can see these models, some of them are hosted on Datarobot, some of them are actually hosted on GCP. The model that I just showed you the documentation for, this is that model. And what you can see here is that this model did 201 predictions per day. But more importantly is this idea of data drift and accuracy. So when I go in, dig into the model, this model actually predicts hospitalizations. I can see that the number of patients hospitalized on this model since it went into production, 72% of them are hospitalized. Whereas when we trained the model, only 40% of patients were hospitalized. That's a problem. That means this model has basically been trained in an entirely different environment than what's currently in production. And that's why data drift is really important to track. Across hundreds of thousands of models deployed on Datarobot, we estimate that models will decay, their performance will start to drop off by 5 to 10% per year. And actually, we have a chart of accuracy here. Oh, I haven't uploaded actually. So I'll pull up a different model.
Sorry for the interruption.
No.
This is an interesting area. So the Vertex AI and the Datarobot, they have a lot of overlap. Like the data drifting, monitoring, there's a similar function. I see the documentation looks like there's a hook between Vertex AI and the Datarobot.
Mhm.
So Vertex AI can link to, like, utilize the function in Datarobot to generate documentation. I know Datarobot can basically do this kind of things for any model as far as there's a hook over there.
Exactly.
But for the data drifting, like the specific one, the Vertex AI one, is the data drifting part done in here or in Vertex AI?
So the data drift is calculated here. And one of the reasons why, I'm going to actually click on a tab called prediction environments, is you can see I have a combination of Datarobot prediction servers, GCP, on-prem, and Azure. And I can, and this is another key thing. How are you going to monitor the predictions no matter where you're making them? So I can monitor models in all of these contexts, all from a single screen.
Oh.
Yeah. Okay. And we were just taking a look at accuracy there as well. Kind of again, why is this important? This is actually from another one of my customers. Oops, too far. The area of this chart, so they launched a model that looked at the delayed shipments out of a distribution center. And in the first month of that model, they were able to avoid $1.1 million in penalties related to delayed shipment. They're shipping consumer goods to basically supermarkets. So if they don't arrive on time to the distribution center, the purchaser can actually dock 5% of the order cost. So when you're shipping out, $20 million worth of product a month, 5% gets docked off because your shipments are late, you start losing a lot of money. So in the first month, they avoided $1.1 million in penalties. That was a huge victory. And I can tell you, as a sales engineer mostly, we won this contract on that figure. But a year later, they were only avoiding $900,000 a month. So what happened to the missing $200,000 to $300,000? Well, it comes from not monitoring and keeping up with the modeling going forward. Because once you have AI predictions, you're going to start using them. You're going to change the experiment. You're going to change the environment. And it's systems like these that track accuracy, that track data drift, that enable you to sustain whatever advantage you had over the long term. That's why I call this time on vacation, because you better believe a year later, somebody noticed that the fees started ticking up again, right? And once that happened, somebody was able to go into Datarobot and say, oh, whoops, I'm on the wrong tab. Give me 1 second, guys. I hate Zoom. Gotta get this thing out of the way. Somebody is able to go into Datarobot and say, well, look, we have a new deployment ready to go. It's been retrained. It has higher accuracy than the one that we had previously. We can swap it in and we'll start earning that value back. That's the important use case. And it's only made possible because behind the scenes, we can constantly spin up new models to understand. Behind the scenes, we can spin up new models. We can pull active data sets. We can derive new features and accelerate that as much as possible.
Question.
Yeah.
Yeah, so I was just wondering, does Datarobot, can it automatically still update, the data from the, SQL side and then update your model in data model real time so that you don't need to wait for a year before you are okay, I need to get a new model. Can I do that real time every day?
Yeah, so that's actually exactly what's happening here. These models are retraining every day. And actually, I'm going to show you actually on the Vertex side how we script this. So you can see here, I'm in Vertex and I have train and deploy, and I have this set to actually run every single day. So it last ran today, it's in Central Time, I think. And you can see I run this about every day. So back running on the 19th, I ran it on the 18th. And what happens in this pipeline, you can see I also run the predictions every single hour. And what happens on this pipeline is it'll retrain the model, it'll re-pull it from BigQuery, regenerate the model, upload it to Datarobot, generate a new version of the documentation so I always have it up to date. So the answer is yes, absolutely. And we call this continuous AI, that your model should be ready in the background continuously as you go along. And I won't sugarcoat it. If you change the data underlying it significantly, start dropping a bunch of columns, you'll run into some issues. But if your data is going to be consistent, yeah, we're going to retrain models and change them as you go.
How this connection work is you have a code in the Vertex AI calling the Datarobot library, right?
Yeah, that's right. Yeah, I don't mind bringing it up for you all.
Can you show us the code?
Yeah, of course.
Well, the code is on Vertex AI side, calling Datarobot API, right?
That's right.
Or
Yeah.
That's directed. Is the code on the workbench or on where? This might be too deep.
Yeah, no. That's totally fine. Yeah, so I don't mind telling you. So working through this demo, yes, I have some of the code on Workbench. This might get overly technical. So you can see here, I have a function on Workbench. And my workflow is I typically prototype the function calls and the methods and the API calls on Workbench first. But then I actually do some of the development locally, especially for Kubeflow. I'm actually switching projects locally. This is what the pipeline looks like. So this is the training, this is the upload to Vertex, the upload to Datarobot, the compliance documentation. So the reason I like to do this locally in VS Code, I'm not here to push IDEs on anybody. Kubeflow uses a ton of Python features for type checking, and you don't get that automatically in Workbench. Because you have to basically output a file, and then, so if you do it locally, you can take advantage of a whole bunch of typing that is available in the Kubeflow SDK. So I typically do it locally. And you can see the last part of this is actually there's a compiler that takes this Python and compiles it into a JSON object. And by rapidly compiling it, which is just frankly easier to do locally, it'll predict errors that you're gonna have before you deploy it. So I actually do a lot of
Are
this
you
locally.
showing the same screen?
Oh, I'm not showing
I
it.
got a different screen, I think.
Yep.
Oh, I do, you have 5 minutes.
Yeah. Sorry, here we go. Get that out. Yeah, so here we go. So this is the pipeline. There's a training job, upload to Datarobot, generate and post compliance documentation. And as I was saying, this is actually this actually compiles to JSON, which we then use. So I like to do this locally. I should also say, not everybody can code this. This is really complicated. Every single one of these functions is containerized. It goes across an entire Kubernetes node. So it is also helpful to be able to go into a UI and just hit create report, and it'll create the report. You can also go, the model, it gets put in what we call the model registry. I mentioned I build this model every day. So we're on model 42. I just need to drop the file in here and it creates version 43. And then it'll build the project. So you got to support both use cases. Because not everybody's going to sit here and code this up. Yeah.
What happens when you upload it here? Sorry.
What happens when you upload it here, Chandler? Did you set me up for that? Okay.
Testing part.
Yeah. So when we upload it here, so here's volume 42 tested. This happened, when did this happen? Well, we could look at the log and see actually when this occurred. But the tests are, first off, can you even make predictions from this? So does the container you're using with the model make predictions? So that's the first one. The next one is null imputation. So a lot of times you're calling for a prediction from something like a web application. What if you're calling it from someone filling out a form online? They don't fill out a specific field. You're going to call it with a field missing. How's the model going to handle that? We call that null imputation. It's a major problem in machine learning. You have to decide if or how your model is going to do null imputation. So we just run a test here to make sure the model can do that and it's not going to crash. Side effect, I mentioned you have to scale from 1 to 1,000,000 predictions. So I'll tell you, when I learned to do data science, you could do things like calculate the median and then use the median in null imputation. The problem is when you do that, if you get 2 predictions instead of 1,000,000 predictions, there's no median. It'll just pick a value. And now your model is totally off. So what side effect testing is it's looking at, okay, I'm going to do all the predictions all at once, and then I'm going to do each of them one at a time, and I'm going to make sure the prediction's the same. There's no side effect by doing the models in different ways. And again, there's other tests here that I didn't turn on for this, for performance and stability and so on and so forth. Again, this is really critical. We have customers who are putting models inside servers at the trading floor so they can take advantage of the distance to do currency trading or whatever. They need to know that this is verified and ready to go before they have Kubernetes deploy that model where it's going. So this is what those tests are for. Yeah, and actually, if you look at the log, you can see the predictions they kind of output in here, and it shows you all the tests. All right, I think I have one more slide, and then I'll just take questions. So this is just sort of so what do you look for? To kind of summarize, take advantage of a cloud to integrate, ingest data, and put it in these amazing data warehouses. I know they're doing a BigQuery presentation next door, which I'm sure is really great. Take advantage of that, and then layer your AI framework on it so it can take advantage of all that. And so that it's actually accelerating what people are really going to be doing, which is coming up and discovering features and iterations and experiments. That AI layer should take advantage of the infrastructure the clouds are providing. And Datarobot does this. We're essentially taking advantage of Kubernetes, sort of, I'll admit, taking advantage of Kubernetes to allow us to build 60 models all at once, or in fast succession. Once the model's arrived on, you can leverage the services again to host it for predictions. So if you want to make predictions in a, with 100 gigabytes of RAM and an NVIDIA GPU, they're going to make that happen for you. It'll cost you about $14 an hour, but they'll make it happen for you. And in addition, you can interoperate to publish things like metadata and documentation of the model where it's needed for your stakeholders. So if you want to think about an ideal architecture for Agile AI, that's why I present it. And it is portable through, although there are differences between the different hyperscalers, they all roughly have these blue boxes and some of these white boxes. And you can make this happen if you focus on the true accelerators for the users. And those are, how do you going to discover and exercise new features? How fast can you prototype and scale new models? How explainable are the results going to be? And how are you going to monitor and govern those models over time? All right, that's kind of my last part of the spiel. Any other questions? Now we'll do a quiz. Nobody did a quiz. That's like an old conference trick. You pull up a multiple choice question. Yeah.
I guess the one question I have is, I think objectively, model management and monitoring just makes perfect sense and it feels extremely critical. Have you found, but when I talk to customers, not many of them actually have a process in place or actually doing it. Like, why is that?
Well, why is that? So speaking from my own experience, one reason we didn't totally monitor models sometimes in previous engagements is that we would retrain the model every month. So if you're only performing scores monthly, you just retrain the model before you run it. And while you retrain the model, you hopefully have a data science stepping through it and looking at those different metrics and making sure it still works. But more and more organizations, as I said, as the demand for models grow, even if you're only running them monthly, you don't have time to do this, right? If you have 50 models, even if you only run them monthly, if you spend a day each model making sure it still works, you don't have time to do this, right? So that's part of it. It's like really early in the life cycle, you had very few models, they weren't running in real time. This wasn't spread. So there's just a time factor there. I think the other one is, again, the ability to orchestrate behind the scenes, running all of this testing and doing all of the bookkeeping on the back end to make this work. And that bookkeeping is, this rose from the training data, this rose from the scoring data, it arrived here. The actual result, which I'm going to use for accuracy, is coming from here. Like, that's a lot of bookkeeping that you have to orchestrate. And so I think it took a while to just originate some of those metrics and statistics, but and so they haven't penetrated yet. Yeah.
Well, I actually have two questions, but the first one is well, a little bit sensitive, right? So I see a lot of overlap between Vertex AI and the Datarobot, right?
Yeah.
So Vertex AI is native on ChatGPT, right? And the Datarobot need the actual installation. So if we want to define like the biggest advantage to go for the actual step, because like the Datarobot really did a great job on the graphic and on the analysis, on the data drifting, like follow-up monitoring. Vertex AI is kind of catching up doing that. We went through several of those
Sure.
kind of conversations. So is there any competitive advantage like by going to Datarobot, provide better service?
I mean, to some extent, some of the things I've already touched on here, the idea of feature discovery and automating the preparation for AI and machine learning. Vertex AI and Dataplex are really good data catalogs, but they're not going to give you an idea of what feature you should have or should use. So that's one. So again, go back into that room and talk about, whether it's regexes or counts or summarization, you have to come up with all that. That's feature discovery. The other one is, we talked about monitoring and model management. There are definitely differences in the way that we're approaching it and the features that are available when you kind of drill down underneath it. I should also say Vertex AI has things that they do well as well. And that's why, and the same is true of SageMaker, and Azure ML to some extent. That's why actually we work really well together. Experienced data scientists who want their own GPU accelerated instance that they can kind of do anything on, who are even experimenting with their own estimator, like their own version of XGBoost, whatever it is, they're going to have a great time on Vertex AI, right? For other data scientists who are not going to automatically containerize their code within a notebook, they're going to have some frustration. And it's also not built for this kind of interactive workflow that we're working on right here. So in some extent, they're starting to focus on different users, right? And then there's also a lot of places where they work really well together. You can see in this pipeline, we're kind of taking the advantages of both systems. So we're doing a set of training on Vertex AI, which is fantastic, but then we're also pulling in the explainability and compliance features that are coming from Datarobot, and you can use them together, right? So it doesn't have to be either or.
That's actually also related to another question, right? The traditionally, the data scientists, they has their focus on algorithm, how to train the model.
Yeah.
But one right now working on the MLOps tool, like a Datarobot. It's kind of like we have to have the data scientists integrated with a lot of orchestration work, or even kind of like a DevOps type of work, and it will still kind of derail them from what they were really initially trained for. So how any best practice in the industry, like do we normally have a separate ML team to do that, so that offload the work to the data scientists and keep them focused on what they were built for and what they were trained for. But at the same time, if you do not have enough knowledge on the data science itself, algorithm itself, it's really hard to manage the orchestration really effectively. So how to address that problem? How to from the organization level? What's the
I see you perk up. You want to take this?
Oh,
No, I'm happy to. So most organizations, and one of the reasons I think Datarobot really invested in this area of MLOps is to allow operators, whether those are DevOps people, cloud infrastructure people, who feel comfortable overseeing models in production. So they're getting all sorts of supports and metrics and dashboards and documents to help them do that, so that you can free up data science time to innovate on new areas. I think that's actually the driving force behind functionality like this. Absolutely. Then there's a flip side, which is, are you giving a data scientist a tool that they need a software engineer to learn? I'm not picking on Tony here. We just released an open source package. Oh, you're here. You're still here. We just released an open source package of how to incorporate a Datarobot model in a Jenkins pipeline. No data scientist is learning how to do that. It's just like, and then there are some Kaggle tutorials and some advantages. So you also don't want to give them a tool set where they can only be successful if they get an entire software engineering background. I'll illustrate this through my code here. This is the code that Vertex runs to build the model. It's using shared secrets coming out of Kubernetes and delivered to the model via environment variables and arguments. So in my head, as I kind of code this, I need to be aware of the fact that when this model is ready to be serialized and deployed, it's not going to just get saved in a directory. It's got to get saved to a location in an environment variable that will be available at runtime, but is not available as I develop it now. That's an extremely difficult concept that I got wrong 100 times before I figured it out for this demo. And the documentation is all there and it's all good and it's all helping, but it's just continuously adding it. Now, what actually happens underneath the hood is when you run this in GCP, a cloud storage bucket is virtualized as a directory that allows it to be saved through a normal, all these things, but you got to keep all of that up and in your head, and it's hard. It's hard.
No, I would add to that too. I mean, if you go back to a blueprint in Datarobot, just that concept of serialization and the complexity. When we look at best practices, especially with advanced data science teams that are leveraging GCP, what Luke was just describing, like the need to be super aware of the DevOps simplification of your training pipeline. That's all abstracted away. That's something we started a while ago, but that's also included when you bring your own models. So when Luke uploaded the Vertex AI model into our MLOps, the whole concept there is to how do we streamline and simplify the containerization and just exposing an API endpoint. So as a data scientist, your job is to spend more time thinking about the business problem you're trying to solve and the right way to do it. And when you're ready to deploy, there's just an endpoint that's available. It's always going to consistently store your data. So the other thing too, going back to like the differentiators of where we see, especially at a very large retail company that's turning through lots of models as kind of data scientists, where there's a complement with Vertex, it's just around time to value. And so if you have multiple data sets and you're trying to solve a new problem, you should be able to understand where the signal is within like a couple of hours, not longer than that. And that's sort of the best practice that everyone sees, or that we use in the field is, let's get into Datarobot, understand what features are driving value. Is there a signal? Is there leakage? That can be really messy across all the data sets. And then, just collapse that time to getting to a decent answer. And then if you want to, if you want to code your own custom large scale computer vision model, like sure, you're probably better off doing that somewhere else, but there's just trade-off on the different use cases. So it's kind of this 80-20 rule of like, when you really need to focus on time versus a ton of compute and maybe a more bespoke class of problem. Does that make sense?
Yeah, so it's been about, this is where I'll close. It's been about 1 hour. All these projects are now done and completed. So I have all 5 models that we kicked off have all been run on all the data and are ready to go for my work. That's about it.
Drop the mic.
Yeah,
Let's go through.
Yeah, all right, let's do it.
Somebody going career room, so maybe we can have just go out on a out there.
Tony, well, we gotta get you from the other side. I'm surprised you still have this. It's just like left